Hello, Math Masterminds. Today we're going to be talking about proportional versus non-proportional relationships. We're going to be looking at tables, graphs, and equations. When we're given a table, there are some indicators to let us know that the information creates a proportional relationship. For example, when the table has 0 for the x value, 0 for the y value, that tells us when graphed, it will go through the origin and it creates a proportional relationship. Sometimes the table will not show the x value of 0. That's when we will have to use another method to determine if it's a proportional relationship. We will then take the change of y over the change of x, simplify to create ratios. If each ratio is equivalent, that's an indicator that the information in the table creates a proportional relationship. So once again, if we create equivalent ratios, we have proportional relationship. When x is 0 and y is 0, which means when graphed, it will go through the origin, creates a proportional relationship. However, some tables, we're not given a proportional relationship. So when we have tables, we can identify non-proportional relationships pretty much in the same way. When x is 0, my y will not be 0, which tells me that's not a proportional relationship. Instead, it tells me the y-intercept. When graphed, that's where the line will cross the y-axis. When the table does not have an x value of 0, we can still create ratios by change of y over change of x, but the ratios are not going to be equivalent. So each time we create change of y over change of x, we will get a different ratio, which tells us the information is a non-proportional relationship. Okay, so keep that in mind. With graphs, we can easily identify a proportional relationship with a graph. If the line goes through the point of origin, which is 0, 0, and we see each of these graphs show a proportional relationship because the line goes through the origin 0, 0, and we see a straight line. Some graphs do not go through the origin, and those create non-proportional relationships. Once again, it tells us the y-intercept because that's where it will intersect the y-axis. Notice this last image, the line starts at the origin, 0, 0, but it's not a straight line. Therefore, when I create my ratios here, they will not be equivalent. With an equation, we're going to look for a coefficient with a variable. We're going to look for the equations that are represented y equals kx or y equals mx. And that's basically what we see here. Each one, we see a form of y equals kx. Y equals a coefficient and a variable. Y equals a coefficient and a variable. That tells me it's a proportional relationship. In an equation, I can see a non-proportional relationship when the equation is in the form of y equals mx plus b, which means I am now given that y-intercept, which is my plus b. So notice we can use plus or minus a constant, which is represented by b. Remember that constant is that one-time value, okay, like a membership fee or a service fee. So with non-proportional relationships, we're going to see equations in the form of y equals mx plus b. In each of the examples that are given, you see that plus or minus a constant.